Welcome to Engineering Funda family. This video is a part of Network Theory lecture series, and in this video I'll be going to explain you Phasor diagram of RLC parallel circuit. We have already seen RL and RC parallel circuit. Now I'll explain you RLC parallel circuit, and I have already explained RLC series Phasor diagram also. So here relatively you will get to know how to understand things in terms of Phasor diagram. So let us see first how Phasor diagram is there with RLC parallel combination. So if you observe here, RLC are there in parallel and voltage is connected in parallel with all three elements. So here for parallel connection we will be considering voltage as a reference as it is common for all three elements. So for parallel circuit voltage will be same. So I will be taking voltage as a reference for Phasor diagram. So let us consider V of t, that is Vm sin omega t, and in terms of phase you can say V bar, that is maximum magnitude is Vm and angle is 0 degree. Now my dear students, we need to understand phase of current as we have phase of voltage. So here if you observe, we are having this current IT that is divided into resistance, let us say that is IR, here with inductance it is IL, with capacitance it is IC. So here current is getting bisected over here. So let us find first what is IR. So when you talk about IR in terms of phase, it will be voltage in terms of phase divided by resistance R. Now we have already seen voltage in terms of phase, that is Vm angle 0. So Vm by R angle 0, that will be IR in terms of phase. Now what will be IL in terms of phase? So IL in terms of phase will be V in terms of phase divided by impedance ZL. Now V in terms of phase, that is Vm angle 0, and ZL, that is J omega L. Now here magnitude will be Vm by omega L, and you see J is having 90 degree phase. So in numerator it will be minus 90. So I can say 0 minus 90 means minus 90 phase that will be there with IL. Now let us calculate phase of current IC. So IC is equals to voltage in terms of phase divided by impedance of capacitance. So voltage in terms of phase is Vm angle 0 and impedance of capacitance, that is 1 by j omega c. So this omega c will go in numerator and you will be having magnitude, that will be Vm omega c into angle will be 0 plus angle of j, that is 90. So I can say total angle is 90 degree. So now we have IR, IL and IC, and if you apply KCL at this node, let us say this node is V, total current IT, that is equals to leaving current IR plus IL plus IC. So here IT is I in terms of phase is equals to IR is IR in terms of phase plus IL in terms of phase plus IC in terms of phase. Now my dear students, I'll explain you this calculation by just substituting IR, that is Vm by R angle 0, IL, that is Vm by omega L angle minus 90, and IC, that is Vm omega C angle 90. So my dear students, now we have phase of current and phase of voltage. So we can have Phasor diagram of this RLC parallel combination. Now when you want to plot Phasor diagram, first of all you should see what is reference. So reference is voltage phase, that is having magnitude Vm and angle 0. So first of all I should be plotting voltage with angle 0 and its magnitude is Vm. So this is my reference phase. Now my dear students, let us plot current phase. So it is having three components, IR, IL and IC. So now what I'll do is, I'll be plotting first IR, that is having magnitude Vm by R and its angle is 0 degree. So it is having angle 0 degree means I need to have parallel line which is overlapping over phase of voltage, and this is my IR, that is Vm by R angle 0. Now my dear students, let us have IL in terms of phase. So that is having magnitude Vm by omega L and phase is minus 90. So when you plot IL, it will be having minus 90 degree angle. So minus 90 degree means it will be going towards downward direction and its magnitude is Vm by omega L and its phase is minus 90. Now when you want to plot this IC, so that is having magnitude Vm omega C and its angle is 90. So here I am plotting IC, you observe, and IC is having magnitude Vm omega C and its phase is 90 degree. Now my dear students, let us assume here this IC is greater than IL. There can be two combinations. You can have IL greater than IC as well as you can have IC greater than IL. So first I am considering IC greater than IL. So as if IC is greater than IL, then difference of IC and IL, that will be positive. So I can say it will be over here. Let us say this is IC minus IL. So resultant of this current, that will be line joining from here to here. So this will be my current I in terms of phase. Let us say its magnitude is Im and its phase is phi. So that is what? This angle phi. Now there is one more possibility in which I will be considering IL greater than IC. So now I will be considering IL greater than IC. You see IL is larger than IC. Then you will be observing difference that will be there in downward direction. So this will be my IL minus IC. So magnitude of this current, that will be line joining from here to here. So this will be my current in terms of phase, that is magnitude into phase angle phi, and angle will be this phi, right. Now let us try to identify how to calculate this phase phi and how to calculate this magnitude Im. So see, magnitude, that is Im, and that magnitude will be as per this triangle. You can apply Pythagoras, where magnitude will be square root of this component square plus this component square. So you can say that this component is Vm by R whole square plus this component, that is IC minus IL. IC is Vm omega C minus Vm by omega L whole square. So that is how we can have Im. Here we can have Vm common from this. So if I take Vm common from this, this will be square root of 1 by R whole square plus, now Vm is outside, so I can say omega C minus 1 by omega L whole square. So that is how we can have magnitude of current. And if you want phase, then phase of current, that is as per this triangle, you can say tan inverse opposite divided by adjacent. Opposite is IC minus IL. So I can say Vm omega C minus Vm by omega L, that is IC minus IL, divided by IR, that is having magnitude Vm by R. Now my dear students, let us try to understand, as if you have inductive network or capacitive network, then what will happen with phase of voltage and current. So here you see IC is greater than IL. What it means? This network is capacitive network. So for capacitive network, you will be observing that this current is always leading with respect to voltage. And here you see IL is greater than IC. What it means? This network is inductive network. So for inductive network, you should remember always voltage will lead with respect to current. Now this is parallel connection, and here we have magnitude of current and phase, and I can explain you that in easier way to remember, and for that let us consider this network with its parallel connection. So for parallel connection, impedance will be 1 by Z is equals to 1 by ZR plus 1 by ZL plus 1 by ZC. 1 by Z is admittance, so let us write Y, and 1 by ZR is 1 by R plus 1 by ZL, that is 1 by J omega L plus 1 by ZC, so that is 1 by 1 divided by J omega C, so J omega C will come in numerator. So here you see this Y is equals to 1 by R, that is real component, and plus if you take J common then omega C, and if you take J in numerator it will be minus 1 by omega L. Now if you want to represent this admittance in terms of phase, then you see it is having magnitude, that is real component square plus imaginary component square. So square root of that will be having magnitude of admittance, and if you observe phase then that is phi, that will be tan inverse imaginary component divided by real component. So this R will come in numerator into omega C minus 1 by omega L. So this is my phase and magnitude of admittance. If you observe phase of current, so that is similar to phase of admittance, right? And even you can identify this value of current as per I is equals to voltage in terms of phase into admittance in terms of phase. Voltage in terms of phase here it is given, that is Vm angle 0, into admittance in terms of phase, that is this. So I can say I, that is Vm into square root of 1 by R whole square plus omega C minus 1 by omega L square into phase phi. So that is similar to this. So my dear students, only one thing that you need to remember: for parallel connection, phase of current will be phase of admittance, and for series connection, phase of voltage will be phase of impedance. And one more essential point that you must remember, that is for inductive circuit, voltage will lead with respect to current, and for capacitive circuit, voltage will lag with respect to current. And these are the points that is very essential to solve problems, so you must remember it. I hope you have understood this. Thank you so much for watching this video.